Welcome to this audio tour where I'm going to discuss some of the features of glaucoma in the dog as an example species. We talked about glaucoma being defined as retinal and optic nerve damage that is most commonly associated with elevated intraocular pressure, and I'm just going to walk you through an example of that in a dog to helpfully cement those concepts. So if you'll remember, we talk about aqueous being produced by the non-pigmented ciliary epithelium of the ciliary body, pumped into the posterior chamber, through the pupil into the anterior chamber, and then it eventually makes its way into the iridocorneal angle. And for the purposes of this audio tour, we're not going to discuss the difference between conventional and non-conventional outflow. Simply be aware that the occlusion of outflow occurs in the front of the eye, generally either at the pupil or through disruption of the iridocorneal angle in our domestic animals. You may notice even from this magnification that the iridocorneal angle in this dog is not entirely normal, in that his pectinate ligament is much thicker than normal. You can see a big sheet of it extending from the iris base to the end of Descemet's membrane, and this is a type of glaucoma in dogs that doesn't really happen to other species. The cause of glaucoma is irrelevant for this discussion, but this is the one that we're going to use in this example just to highlight the concepts. So when you have an elevated intraocular pressure situation, it's important to realize that the pressure affects the entire globe, despite the aqueous portion being limited to the anterior and posterior chambers. When the pressure is elevated, that effect is felt all in the globe, on the retina, the optic nerve head, the corneal endothelium. So it is a pan-ocular disease. And now we're going to focus on the changes that occur at the optic nerve head. I'm going to jump back there just to remind everybody about the lamina cribrosa, which are the parallel collagen fibers that are extensions of the sclera that are perpendicular to the optic nerve fibers. So the optic nerve fibers come from the ganglion cells, which are here. Those axons begin in the nerve fiber layer. They reach the optic nerve head. They pass posteriorly, and as they pass through the lamina cribrosa, they form the fascicles of the optic nerve. It is at this point where the damage of elevated pressure causes axonal injury, which moves retrograde to affect the nerve fiber layer and the ganglion cells, which are the cell bodies of all of the axons in your optic nerve. The thing that we didn't really look at in class is, or in the lab, is what the consequences of glaucoma look like, and we're going to use the same canine primary glaucoma or goniodysgensis example to show you the damage. So we're going to switch to this other eye, and this eye, you can it's hard to gauge size, but this eye is enlarged. The lens has luxated, it's out of position, and you can see even from this magnification that the iridocorneal angle is collapsed. And remember that that is associated with the impairment of drainage, but that does not define glaucoma. What defines glaucoma is the damage to the back of the eye. We've got a deep optic nerve head cup, and we've got retinal atrophy, which is hard to appreciate from this magnification that we'll look at in more detail in just a second. For completeness, we're going to take a peek at this dog's iridocorneal angle, simply to show that a similar arrangement that we had in the other dog, where a thick sheet of iris-like tissue, which is the overly thick pectinate ligament, is now overlying and compressing all of the structures of the iridocorneal angle that we talked about in detail. The ciliary cleft is no longer apparent. You cannot see the trabecular meshwork, and you can imagine that aqueous will have a very hard time getting through this thick sheet, and even if it did, there is no longer the apparatus to drain it. This is why this animal has elevated intraocular pressure. If we zoom back out and we want to look at the damage to the back of the eye in more detail, here we can see that the lamina cribrosa is now posterior. It's a little hard to pick out in this particular dog, partly because it is damaged from glaucoma, but the optic nerve head cup is behind the limits of the sclera. So you know the tissue has been lost, that the lamina cribrosa is bowed posteriorly, and there's been serious damage to this optic nerve. And even in the axons further along the tract. And if we look at the retina, in a random spot, we've got an artifactual separation here in the internuclear layer, but the ganglion cells are largely absent, and that is the classic lesion of glaucoma in the retina, regardless of species. Because again, the cell bodies of the ganglion cells are the origin of the axons that will become the optic nerve. If we move to his non-tapetal retina, or the ventral side, and we look at that in a little more detail peripherally, we can see that the interretinal atrophy is a little more advanced. We have no ganglion cells, the internuclear layer here is very thinned, and we're starting to lose both the inner and outer plexiform layer, although again we still have that artifact, which is unfortunate in the specimen, but I think the concepts can still be gleaned. So again, it's important to remember that glaucoma is a panocular disease where, again, in our domestic animals, impairment of flow at the front of the eye in the iridocorneal angle, or potentially at the pupil, leads to elevated intraocular pressure affecting the whole eye, and the syndrome of glaucoma is defined as the optic nerve and retinal damage that results. So I hope this has been a helpful audio tour, and we'll see you next time.